SecretLabs, and we are very happy to participate in this hackathon. And I'll tell you guys a little bit about secret networks, about privacy, and then we'll have a demo/workshop where our colleague Alex will show how to work with the stuff that we have prepared for you to hack on. Okay, so let's start. So I'm sure you all know that, right? Blockchain today is an open book, right? Whatever you do on any EVM network or most other networks is fully visible, fully transparent. Everyone can see it, so everything you do is fully observed, be it DeFi, gaming, transfers, whatever, right? So this is not the most desirable property of the blockchain, right? Secret is one of the longest standing confidential computing network. So SecretNetwork was launched about 3 years ago. It's a layer 1 network inside the Cosmos ecosystem. And we're using what's called the Trusted Execution Environment technology, which is a computing enclave that runs inside a processor, and everything that goes in this enclave is encrypted, and even the validator, the operator of the machine, cannot see what's going on. So that's how we offer computational privacy. So all the inputs and the outputs going into the smart contracts and also the state of the smart contracts on the network are encrypted, okay? We're using the COSM-WASM runtime, and the main development language for smart contracts on secret networks is Rust. Okay, so as I said, we've been running for over 3 years, lots of transactions, over 111,000 smart contracts deployed, over 300,000 wallets. We have a very rich ecosystem, actually, of apps of all kinds: DeFi, gaming, social, gambling, you name it. A lot of different apps, so it's a full-fledged, very, very active ecosystem. NFTs, you name it. Okay? So that's all very nice. So we've built our network, and we have a lot of apps running on them, right? But the world is not just one blockchain, right? There are so many blockchains out there, and so many potential ideas, and so many apps. So we started thinking, what if any application on any chain could have privacy, right? And we thought about that, and we thought it was actually doable with what we are now starting to unveil and promote, which is we call it privacy as a service, right? So the way it works is actually we are building endpoints or SDKs in different ecosystems, starting with EVM, where people can use their existing apps and add privacy functionality to what they're doing. I'll give you an example. Let's say you're building an app that is a DAO, okay? There are a lot of DAOs running on all of those beautiful blockchains, but let's say you want to have a voting system that is confidential. You want to have a voting mechanism where people's votes are not public, are not seen. So how would you do that? Today, you could build your dApp on SecretNetwork, it's fine, but what if you don't want to migrate all your code? So today, with those capabilities, you would be able to just add the voting module and have all the voting happen on the secret network confidentially, and then in the end, you just tally the votes and get the results, and you know if, say, a proposal won or lost without revealing who of the members voted in which way. And there are many other potential use cases, right? I mentioned private voting. Think about confidential DeFi, right? This MEV front running is very well known. It's happening all the time. It doesn't happen on Secret. But maybe you can do part of your DeFi app on Secret Network and prevent that from happening. NFTs with private content, dark pools, on-chain randomness, threshold wallets, and I'm sure there are many, many more applications which we haven't even thought about, and that's why we're here with you, the hackers, to get those new ideas. Okay? So how it works, okay? How does this magic happen between two blockchains? So we're using the XLR general message passing bridge to pass information between EVM contracts and secret contracts and back. It's working. It's available on EVM network supported by XLR, and gas is paid with a native currency, right? So you don't have to worry about acquiring secret network tokens or things like that. So you just play pretty natively. And this, actually, Alex will soon be showing how to do that. Okay, so we're kind of unveiling, this is like a teaser of our roadmap, so we will be developing privacy SDKs, starting with the basic SDK, which will have very small primitives, like key value store, basic set operations, random number generation on secret. This is also, by the way, feature related to privacy. It's impossible to generate an on-chain random number in EVM because it will be predictable, right? And then later on we'll be building, I hope you can see that, we'll be building high-level SDKs with ready-made modules like voting, like sealed bids and other stuff, which you'll just be able to use out of the box, maybe with small modification, but without the need of really learning, if you don't know Rust, or need of learning the new language. We have some more stuff on the roadmap, but it's on purpose it's kind of blurred because we're still not ready 100% to reveal it. Okay? So, back to the hackathon, right? So we have created those bounties for the hackathon. Any category, privacy as a service, which I was mostly talking about, which we will demonstrate right now. And also a bounty for gaming. So 3 bounties for this hackathon. You know, my personal favorite is privacy as a service because I'm a strong believer in making this privacy available everywhere and anywhere, and I hope you guys, after learning how to do it, you will use it in your projects. And now I'm passing the floor to Alex here, who will show how this is done. If you want, you can grab this this link because it will disappear in a second. Alex will be showing things, how to do things. So if you want to copy it, we'll share it later as well with an example on how things work. Okay, Alex.
Yep.
The floor is yours. Thank you.
Everyone got the QR code? Okay. We're posting it afterwards anyway, so let's try it. Okay, do we see anything? Okay. We just mirror can we mirror this? Let me just pull this into the... no, I'd rather mirror it. Okay, that looks a lot better. Okay, so the idea is the following. What we want to do is to show you 2 things. So the first thing is basically how do we bridge stuff from Polygon, but it could be any EVM chain, into Secret. And then we show you basically how to do it the opposite way, to do it from Secret into Polygon. Right now this is basically just in a beta stage, so we're basically showing you that it can be done, and we're like rolling this out over the next weeks, basically giving you the contracts and doing the full implementation. But to give you a rough example of what we're doing, this is basically what we have in Solidity. This is basically on the EVM side, and what you do is you simply basically can import this contract here, and then you can... Oh, can be a bit bigger? Yes, of course. Does that look better for you? Awesome, okay. What we can do is we can call this contract in EVM space and use that to actually bridge messages into Secret. This is exactly what we can do, and I can show it to you. So what we can do is, for example, we can define Secret here, then use some... We can leave the address empty for now, and for example, just say it like this, and also I can give you a sample address here. And where do we have it? Yes, this is an example contract that we can use. And what we can do is can actually use it to pass a message. This is actually happening on mainnet right now. We can pass a message using GMP to pass a message into secret that will be executed there. Just reload and see if it's actually being mined. And okay, this one actually failed. But we're still basically in beta right now. So this is the one direction that we can do, and the other direction would be from secret to Polygon to actually, so let's say you have some computation that you did on Polygon, you did some stuff on secret, and then stuff is basically coming back from secret back into back to Polygon where you want to store your stuff, or you have your result that you wanted to do. And the way to do it like this, basically we modified some UI here to actually show that in JavaScript. But this is also, of course, will be available in a smart contract. So what you can do is you can do a computation in a smart contract and then say that the smart contract send the information back. And as you can see, basically what you do is you send some gas. Let me just put a bit more. And what you then do, you basically include all of the information that you want here, so the destination chain, destination address, and the payload that you defined. And this is basically where all of the information, the result that you got out of the private computation comes out, and you approve it, and it's going to be sent into XLR for the passing, for the general message passing. So what happens is the message is sent from secret into XLR, and then from XLR into Polygon. And there it's gonna, let me just check it. So here, as you can see, we now have this message that came in from secret that we just called the contract with. It's going into XLR and it's going into Polygon and has its target there. And we basically wait just some time for finality. So basically XLR right now is getting the message, is relaying it into Polygon. It can take some time. So for the sake of like shortening the demo itself, I basically did the same thing yesterday, as you can see. Basically tested yesterday freshly out of the printer press. And this is exactly what happens. So you send the transaction in, it gets approved by the XLR relayers, and the XLR relayer then calls the contract itself on Polygon. And this is how you relay the message into Polygon. And that way you can basically do anything you want. So you can pass any messages from secret into Polygon, whatever it is. In that case, it was just like a simple string that we set for the string returner, for example. In that case, we did it. I did string secret Saturn x ETHRome, and this is basically what we passed on from secret directly in there. But it could be anything you want. So for example, it could be a result of a private voting, could be a result of, let's say, an encrypted blob that you have, some data that you wanted to store there, whatever it is. In that case, it was just a simple string, but you can use it for whatever you like. Yeah, so that's the way to do it. And we're basically right now building this stuff more and more to make sure that basically people just have to use this stuff on Solidity, and we'll basically take care of the rest almost. So the touching points that you have to do with Rust is going to be pretty minimal, to just that you can focus on the Solidity part, the stuff that you can do and that you love. Yeah, I think that pretty much demonstrates everything that I want to show.
Okay, so let's switch back.
Yep.
Yeah.
Mm-hmm.
Okay, so we have wrapping up before questions. Let's see if it will work now. It's warming up, right? Yes. Okay, so that was the beautiful picture, guys, for you to get inspired. I'm a strong believer that today's DeFi and other applications with blockchains are kind of hitting sort of a glass ceiling of adoption, because there are a lot of big players and a lot of big important use cases that cannot be addressed without some level of privacy. Okay, and now that privacy is becoming available through secret, through privacy as a service, we are sure that a lot of new use cases will be implemented, like payment remittance, like confidential DeFi, and a lot of other stuff that we already named, and this will be one of the key catalyzers for the next bull run. if you want to join Secret or get in touch with us, use those links. And yeah, I guess we're ready for questions.
Yes. Anyone has questions?
Let's go back to the bounties, yeah. Wait.
If you wanted to pass confidential information from your app into Secret, how would you maintain the privacy?
The easiest way to do it would be to usually encrypt the data beforehand, and in your contract on Secret that we're also implementing, you basically have a private key that can decrypt that data as well. So you have your stuff encrypted with a public key on ETHRome, send it into the Send it into the smart contract in Secret. It will be decrypted inside of that smart contract. You do some computation on it, and then it gets sent out encrypted again if you want to. You don't have to do it that way. For example, the result can be clear text, whatever you like. That depends on your use case. Yeah.
Thank you.
Hey, so what I wanted to ask, it's first a super cool use case, privacy as a service, and as far as I understood, Secret doesn't use any ZKP, it is another way of encrypting the data. And what I wanted to ask you, this privacy as a service, I don't know if you have, for instance, a benchmark of performances when compared to, I don't know, a ZK-powered app.
Yeah, so we actually have this chart comparing several technologies like TEE, ZKP, MPC as well, and FHE, which is fully homomorphic encryption. So our estimation is that actually TEE is relying on hardware, right? So there is no complex math and complex computations involved. So it is actually the fastest of all those technologies and therefore the cheapest to implement. There are different trade-offs, right? Because in TE you are relying, specifically in our case, on Intel, which is a very reputable company, but still there is like a certain point of centralization. So we think that in the future, actually, instead of just Secret here, we're building a constellation of different technologies where the users will be able to choose, right? Because if you want to secure your private keys for $1 billion enterprise, maybe you are not reliant on Intel, right? Maybe you want to use some much more expensive, say, FHE technology or ZKP. But for a card game or for a lot of other applications, TE is just fine. Or DAO voting, right? So it's all perfectly fine. So there will be several technologies in play together for different use cases.
Okay, thank you.
Same way as the blockchains, right? You have Polygon and Ethereum because this one is more secure, this one is cheaper, and all the others, yeah? So it makes sense.
Yeah, thank you. In the end, it's a trade-off, and I think the integration part, it's really what the important part here, because it will save a lot of time. Probably it should be easier.
Yeah, that's actually our goal. We're just starting this work now on building out those SDKs, and ideally we wanted to make it so that the EVM developer doesn't even need to know much about SecretNetwork or develop anything, or maybe just modify things a little, rather than just learning a new language, which is always hard.
Yeah, thank you. It will be a black box in the end.
Yeah, exactly. That's the goal, and that's actually the roadmap that we will be executing on.
Thank you very much.
Thank you.
Anyone? Bye.
Thank you very much. It was a pleasure. Thank you.